Alright, so today we'll be learning about the Gauss-Jordan elimination method. And what this method does is basically it solves linear equations and it finds out their solutions in a very easy form using matrices. And how we do it is you can have a linear equation and you put the numbers of that equation in a matrix form and use this method. And what it does is the diagonals, it will change them to 1, and all the other numbers, the zeros above the numbers above the ones and the below the ones, they will be turned to 0, and the solution you get from it is the answer. And when it is reduced, the form of that matrix is called the reduced echelon form. And let's get into it. So in this code, I have first defined a Gauss elimination matrix. This is the method that I'll be using for this, and this is the line for the length of the matrix that I've used here. And one second. Alright, so here it is the partial pivoting. So the partial pivoting step, this is used to ensure the numerical stability by swapping the rows to make the pivot element, which is the diagonal element, the largest in magnitude. And we have to keep notice of such stuff while we write codes for things like this. So there there are no or minor errors. And after this is the line for making the diagonal element 1. As I already told you guys that we have to make the diagonal element 1 in order to complete this reduced echelon form. So this line that I have used here, it is just to make the diagonal elements 1 to make sure that the process is done perfectly. And over here I have mentioned that if the divisor is equal to 0, then it will preview this error message because there will be no other rows in the matrix. That means it will probably be a 1 by 1 matrix, and that is not possible for this. So that is what I've done here. And now moving on to the next section, it is to make the other rows 0. And of course the first of course you have to make the diagonals 1, but with that you also have to make the numbers above and below the diagonals 0 in Gauss Jordan. So this is the code that I've written for this section. And now let's move on to the next section. Now in this section it is to display the final matrix. Now it is an optional part that you can add, or you can even remove. The code will still run without it. And what this one does is it will just display the final matrix after it has been reduced to the echelon form with the zeros and the diagonals as ones, just to show you how the matrix looks after it has been solved. Now moving on to the print solution function. Now this function, this is used to print solutions from the last column of the matrix, and they are on the in the linear equations, they are on the equal side, and when we put them in the matrix they are on the most right column. So those will be our solutions at the end of the reduced echelon form. And after that, here's the main function that firstly takes input from the user. Now you can also hard code the input if you want, or either you can take the input from the user. What I chose to do here is I took the input from the user, and in the first line you can see that I've given that the user has to first enter the number of variables. Now what I mean by this is there are different dimensions of a matrix. There can be 2 by 2 matrix, 3 by 3, 4 by 4, and as long as imagination goes. So if you put 3 in here, then you will have a matrix that is 3 by 3, but that will not include the part that is the right column. So it will actually be 4 columns, but it will be 3 rows, because the rightmost column, that will not be reduced to anything. And after that moving on to this, and what this does is it just performs the Gauss elimination that we've written the code for in the whole thing, and it just performs the whole process and reduces the echelon form. And what this one does is prints the solution, which is the rightmost column again after the matrix has been reduced. And this is just to avoid errors over here if there are any value errors, so it will just prompt up an error and let us know. And what this here is, it just executes the main function if the script is run as the main program. So let's go ahead and run this program to get a clear view of this. So let's go ahead and alright, so as you can see here, it is asking me for the number of variables. So let's say we wanted 3 by 3 matrix, so I will enter 3 over here, and now it is giving me now it is asking me the augmented matrix. So what the format I have used here, it is like this. So just watch what I type. Let's say 1 0 2, and you might be thinking, okay, that's enough, that's 3, but as I told you before, that the rightmost column, it will not be included in it, so it will actually be a 4 by 3, but we will count it as a 3 by 3 because the rightmost column, it will not be reduced. So let's just put anything here, and that is the first row. Now moving on to, you can put anything here, it is totally up to you, it is the input. And let me just fill this out. Alright, and as you can see that I have entered the input and I have gotten the results instantly. And as you can see, I have used float, the float type in this because there I don't want it to round up the numbers to a base value or a floor value or a ceiling value, and I want the accurate results. So you can see that the diagonals here, they're 1, and the numbers below and above them, they're 0. And just repeating again, the rightmost column, it will not be reduced, it will just go on as the rows are computed, and we will not have to reduce them separately. And this is the solution. These are the values of x1, x2 and x3, which we get from here. And that is my code, and thank you for watching.